UK Rainwater Harvesting Association, and I'm sharing the platform with my colleague Neil Pendle of WaterScan, who will be covering grey-water recycling. The title of my section, doing what it says on the tin, quite apart from pinching somebody else's slogan, is quite intentional, because one of the things about rainwater harvesting is that, subject only to the fact that we don't know exactly how often and how much it's going to rain, in all other respects, rainwater harvesting is a very predictable technology that does do what it says on the tin. Where we are in this country with rainwater harvesting is that the total size of the UK market at the moment is about 10 to 15 million pounds, i.e. it's quite tiny, compared to Germany, for example, where it's more like £1 billion per year, or it has been until recently. But over the last 5 years, the rainwater harvesting industry in this country has been doubling year on year, even through the beginning of the downturn in the construction industry. It continued to grow at about 10% a year, and in the last 12 months it's grown at 25%, and I think there's a fair prospect that it will get back to its doubling year on year into the future. Well, why is that? Basically, what we'll be covering, have we got the technician there? I'm not getting on screen what's coming up here. Is the technician there? He's not. Okay, I'll manage without it. I'll have to keep glancing up here. So basically what I'm going to be covering is, first of all, why is it's doubling year on year? What are the industry drivers? Showing you or demonstrating to you how the technology, rainwater harvesting technology, lines up with the industry drivers, and then giving you some typical system performance examples coupled with the carbon footprint impact that they have. So the industry drivers, why is the size of the industry growing? Well, above all else, it's water shortages, water shortages, water shortages, which sometimes in the UK can seem a bit of a strange concept, in that it forever seems to be raining. Well, that might be so, but finding its way into our mains water system is a different story, and the country's water supplies, mains water supplies south of the Humber, are under, in many cases, serious stress. It's been a long-standing issue of surface water management. The previous seminar was talking very much about that, and rainwater harvesting does integrate very well with on-site surface water management issues. I've put question marks after sustainability codes such as BREEAM assessments and the Code for Sustainable Homes. The question mark isn't that these are not industry drivers, but exactly to what extent they will be industry drivers, a very great extent or a lesser extent. And similarly with building regulations, I'll be covering exactly what is changing in building regulations and why that's driving the industry forward. Water shortages, first of all. This is a fairly dated Environment Agency map, dated 2007, but things haven't got any better over the last 3 years. In some respects, they will have got worse. And what it typifies, off the key there, is that anywhere on the eastern side of the country and the south of the country where there's a density of population, the water supplies today are already seriously under stress. Even further to the west, except in isolated areas such as around Bristol, then the stress is already moderate. What the Environment Agency are predicting, and so these are their words, not mine, is that by 2050, so this is the sort of time frame that they're needing to look forward to ensure our water supplies, climate change will have reduced the amount of water available to us by about 10 to 15%. In exactly that same time scale, while water supplies are going downhill, they predict the population to grow by 20 million, which is an amazing figure to come from effectively a government department and not one that's very widely advertised. So with less water, in 40 years' time, we're going to have 20 million more people needing to use that water. Also from the Environment Agency report, Water for People and the Environment, they're expecting the average summer river flows to reduce by as much as 50 to 80% over that time frame. they are looking to rainwater harvesting, that's me, and grey water recycling, that's Neil, to become increasingly important in that context. What they are showing over those same timescales, I showed you a sort of 2007 map before. What you're looking at here is the year 2010 on the left, the baseline, and what that is showing is areas in the UK that are suitable for sustaining green agriculture. Even by the 2020s, we're going to lose a lot of land for sustaining agriculture purely because of limitations on water supply. And by the time you get to 2050, with 20 million more people to service, you're looking at, we'll only be able to grow things in the Lake District and Wales, and to the best of my recollection, the only thing they grow there at the moment is mutton and sheep. So clearly it is a vitally important question for the Environment Agency looking forward, even though we feel wet and damp today. Surface water management, it's long been the case that we need to alleviate downstream flood risks when developing new sites, and therefore the need for sustainable urban drainage solutions. Rainwater harvesting plays some sort of role in that, but only a marginal role, in that it does collect water, but eventually the collection vessel is going to fill and therefore will overflow, and therefore the site drainage arrangements still need to cater for the exceptional rainfalls that might arise when the tank is already full. However, it's a very important part of an integrated system. If you think about a big commercial project, a new supermarket or whatever, acres of roof on the top, even more acres of car parking out front, that is going to take a lot of water, and therefore it's a day one issue. What are we going to do with this water? The sensible thing to do with it, if you can't just put it onto your neighbour and flood them, is first of all to hold it on site in a tank. Once you're holding it on site in a tank, you might as well drop a pump into it and use it to flush the toilets and keep everywhere nice and clean. And if there are firefighting requirements in that same property, you've got to have a guaranteed supply of high pressure water to run the sprinkler system. Then all that water is already there, and that is the approach that we would recommend, an integrated system that does all three of those things for you at the same time. In terms of the Code for Sustainable Homes, I showed that with a question mark before. What it says is that at the moment you and I use on average 150 litres per person per day of mains water. That, if you like, is their datum. It does vary greatly from area to area, but that's the national average. What the Code for Sustainable Homes said is that at the lower levels of the code, code levels 1 and 2, that water consumption has demonstrably got to be brought down to 120 litres. Code levels 1 and 2 is where government housing has been built for the last 2 or 3 years, and government housing, i.e. housing association, etc., is now onto code levels 3 and 4, where it has to be demonstrated that the water consumption, mains water consumption, is no more than 105 litres per person per day. And at code levels 5 and 6, which is where government housing will be in 2 or 3 years' time, then it needs to come down even further to 80 litres a day, not much more than 50% of what we're actually using today. So that is one of the ways in which government is addressing water shortages. Building regulations, again a question mark against that. The question mark is not so much about the present, that's absolutely clear, but what's not clear is what impact building regulations will have on the future. So what building regulations say, as from the 6th of April this year, is that whereas before they talked about water in a dwelling, they now talk about 2 types of water. Wholesome for applications such as bathing, showering, cooking and drinking, and non-wholesome for providing it's of an adequate quality to do what it's intended to do, typically flushing toilets, clothes washing machines and the outside tap. So building regulations has opened up 2 types of water. They also very helpfully go on to talk about the potential sources of the non-wholesome water. What is this stuff? And unless you've got an artesian well or a waterfall in your back garden, which most of us don't have, then the two obvious sources are harvested rainwater and grey water, which Neil will be talking about. The mains consumption, it then goes on to say, is not to exceed 125 litres per day, which is a subtle 5 litres different to the levels 1 and 2 of the Code for Sustainable Homes. That 5 litres is an assumption they make that that's how much you're going to use in the garden. But otherwise, the two figures are intended to align. So how will this work in future if you're having a house build or if you're involved in the house building industry? Well, first of all, you'll have to demonstrate to the building inspector that that is all the water you're going to use. And then secondly, however, if you are substituting water by using recycled grey water or harvested rainwater, then that can be deducted from what it would be assumed your mains consumption is concerned. In doing all these calculations, it's not a question of finger in the air, this is what we think the answer is, Gov. You have to use the government's water calculator, which from a house builder's point of view means you've got to know the technical specification of all the water related goods that have gone into that property and feed those proper technical specifications into the calculator. Similarly, for harvesting rainwater or grey water, the correct technical figures have got to be put in, not your best guess, as far as the building inspector is concerned. And oh, by the way, he will not sign off that property as completed and ready for sale until you have convinced him about that 125 figure. One of the unknowns is how accurate that 125 will be and how much control the builder has got over that. If in fact it's hard to meet that 125, then you'll be wanting to use rainwater substitution. So how does rainwater help in all of this? Well, the basic principles are that you collect from the roof, unless it's a commercial job, in which case you can collect from the car park surface areas as well. It basically is not all that suitable for retrofitting, particularly in dwellings, because of the need for separate pipe work. So in existing buildings, you tend to use it for garden watering only, whereas in new buildings, putting in a few more separate lengths of pipe is not an issue. And the main things you're aiming for is high quality water, by which I mean aesthetically pleasing water. You don't want green looking water coming into your clothes washing machine, for uses such as toilet flushing, clothes washing and the outside tap. The design principles are that you start with the collection capability. How big is the roof? What type of roof is it? What's the roofing material? How much rain is falling in that particular postcode on average over the years? And what of that rain falling on the roof are you likely to lose before it gets into the tank? So that's the best you're going to do, is the maximum amount you can collect. The next calculation you make is, well, how much can I use? There's no point in collecting much more than you can use. And therefore you calculate what is going to be used in that dwelling or building, and you've now got two figures. You take the lower of those two figures, whichever they are, and add what is effectively an 18-day fudge factor, and that is designed to make sure the water goes in and out of the tank, give or take a spoke every 18 days to keep the aesthetic quality of the water that's coming into your toilets and into your clothes washing machine. And as I've said, that can easily be integrated with firefighting and suds in a commercial building. You have a nice big tank, the water comes into a sized compartment, and that's for reharvesting. It spills over a weir into the next compartment, and that's your water for firefighting. It spills over the next compartment, and that's your water for attenuation to meet the suds requirement. So what is the potential then of a typical system? Just using this example, a typical modern building regs property to modern building densities will have something like an 80 square metre roof. Typical rainfall in the driest part of the country around the southeast is around 600 millimetres per year. That will typically yield 40 cubic metres of water per year for non-potable use, which can come off your mains consumption. Typical occupancy of such a building is 3. So the non-wholesome water that's available to you is 56 litres per person per day, which can come off that 150 figure that we were talking about earlier. If you vary that scenario, if you've got a bigger roof, more rain, less occupants, then you vary it linearly. It's a straightforward, the more rain you can collect, the more you've got. The less people you've got, the less people there are using it. The upper limit in a dwelling is around about 70 litres per person per day, because the rest of the water you're using needs to be wholesome water. You use approximately 50% of the water you use for bathing, showering, cooking, drinking, etc. So you can only save the other 50%. So the upper limit on savings on non-domestic buildings can be much higher, because in this building, for example, none of us are going to have a bath. We may all use the toilet once or twice, and therefore a much higher proportion of the water that will be used in this building will be non-wholesome, and you've got a nice big roof so you can collect all the water that you want. So the commercial equation is slightly different. Alignment with the Code for Sustainable Homes. Levels 1 and 2 of the Code for Sustainable Homes, I believe, this is my finger in the air belief as opposed to the government's water calculator, that economy measures such as small dual flush systems, aerated taps, showers instead of baths, smaller wash hand basins and water efficient appliances, dishwashers and clothes washers, would probably bring you from 150 down to that figure. Would probably. But if you're the developer, you can't wait until you built the property to discover that it didn't quite do it, and now you can't sell the house. So that is another area of uncertainty. Will the developers, will the house buyers say, well, let's be clear about this, let's put in rainwater harvesting or grey water recycling, then we know that we're going to definitely come under the 125 limit. As far as levels 3 and 4 are concerned, and public housing is already in this parameter, you've got to get down to 105 litres. You've already done all the right things up here, so you can't do those again. All you can do is either put in very small baths or no baths at all, which might not be very consumer acceptable, or you can say, no, we'll definitely put in rainwater harvesting or grey water, and that will then bring us down to the 105 litres. By the time you get to levels 5 and 6, 2 or 3 years away for the public sector, 2015 for private housing, then you've got to get down to 80 litres. So using the example I showed before of the 3 people in an 80 square metre house, you're saving 56 litres per person per day, which you can take off from the 120 up here, because you're still using the economising measures to get you down to below 80 litres per day. So that's where sort of rainwater and grey water are going to fit in. How are we doing on time there? Still got 5 minutes, okay? I will keep rushing through. The carbon implications, I'm sort of rather approximately quoting from a study undertaken by the Environment Agency, which has not yet been finally reported. So you have to take what I'm about to say with a pinch of salt. Maybe you're taking everything else I said with a pinch of salt, I don't know. But this bit in particular, take with a pinch of salt. And what that study, I think, is likely to say is that each cubic metre of mains water delivered to your tap in your property currently uses around 0.6 kilowatt hours of power to get there, taking it all the way around the system, cleaning it, pumping it back to you, etc. So that's the sort of date and figure in energy terms. Now, each cubic metre of water delivered to you via rainwater harvesting, we think will take, using their figures, we've got better figures that we think we should be using, but this is their figures, uses around 1.16 kilowatt hours of energy. In other words, you have got a carbon penalty for using rainwater harvesting of about a half a kilowatt hour. So taking that as, putting that into the context of the previous example, your 80 square metres, your 40 cubic metres of water you're going to be using on your rain system, multiplying it up by half a kilowatt hour, and the cost of electricity, about 13p at the moment, let's say 15p for round numbers, then you're talking about an additional £3 of electricity per year to save the water you're saving, which is about the equivalent of one 60-watt light bulb 1 hour a day. So those are the sort of carbon comparisons. Nevertheless, we know as an industry we've got to do something about that, and so we're looking at all possible manufacturing and pump efficiency improvements that we can to reduce the carbon footprint. When it's an integrated system on a commercial job where you've already got to put a lot of this in for your suds requirements, then obviously that mitigates the additional impact of including rainwater harvesting. And on smaller developments where smaller property sizes, then you can also bring the carbon down, certainly in terms of the equipment you're installing, by putting in an integrated system or a communal system that serves a number of properties rather than one system per property. So in terms of our national strategy, the fact that we're all going to be eating mutton in about 20 years' time, what is it that we can expect to get? So by 20 million, there'll be, by 2050, there are 20 million extra people, which equals about 7 million extra homes, even ignoring the ones that people need homes now. So there is an additional number that are needed over the next 40 years. Each of those, if they're built to that specification, 80 square metre roof, are capable of yielding about 40 cubic metres per year. So basically, when you build those houses, when we build those houses, we'll be adding 280 million cubic metres per annum to the national supplies, which is a nice big number, but still only nibbles at the national grid delivery, which is currently 6,000 cubic metres per annum. But it nevertheless is a useful contribution. Not only that, we are building houses already for the 20 million people who aren't here, so there's an addition. And wherever it's used in a retrofit or an agricultural situation, there's more to come. So hopefully that 280 million contribution could become something more like 500 million, particularly when the agricultural sector kicks in, because they're the people who are going to be hit by it hardest and soonest.